We're going to test the WebSocket API that we've been building. Right now, all of the API-specific stuff is currently in the root directory. Because we want a different class library to have all the test code in, we want to move all of the API-specific stuff to a directory just called API. So if you just make an empty directory here called API, and then start dragging some of all these files into the API folder. So I'll take these. I'll actually remove the bin here and the object folder, because those are just dependencies. You'll get them back when you build your program anyways. You might not be capable of actually dragging the ws.csproj file, but you can always open up a file explorer and then just do it manually or do it with the command line interface. So a command like mv, and then just point to the file, ws.csproj, and then just point to the directory. And then we can just rename it. I'm going to call it api.csproj to match the folder name. Inside of your solution overview, you might actually get a problem when you do move the file. That's why it doesn't want you to move the csproj file. But you can always re-add it to the solution by just writing .NET sln add, and then the directory where the csproj is inside. And then you can just remove this old reference here to a project, because now you have it here. And when you do make some of the structural changes, always check the project file afterwards. So this one, for instance, was automatically generated and I don't want it to be here. The test project that I'm going to use is NUnit, but you can pick whichever one you want. And I'm going to just call it test. The first thing I'm going to do now that we have the test project is add a reference to the API. The reasoning for this is I'm going to start the API from the test folder. So you don't have to do it this way. You could hypothetically just make a command to start up the API and then run the tests. But this is a slightly more automatic fashion. And in order to actually start this API from the test code, I'll just make a class and then I'll make a method inside of the class. And then we can invoke that. This is actually just the typical old-fashioned boilerplate way of starting an API before we started using top-level statements. I'm not going to take all of the code and put in here because there's one line that I don't want to be executed in the tests. So I'll make a different method here called public static void startup. And now I'm going to take all of this stuff here and just put inside of this method here, except for the console.readline, because that will make the program stall. So I'll put it inside of here. And then I'll just call startup here. So startup. And you can add the args here and then just add a string array here. So now you won't have any compile errors. And this is actually the method that we will call from inside of our tests. So copy this. And since it's a static class, we can just call startup. And I also called the method startup. It's not too important what it's called, but this is just what's going to start up the WebSocket API on port 8181 by default. And now we're ready to start sending some messages to the API while it's running. So there is one library that we're going to use for the tests that is not already pre-installed. And it actually exists in here. And I know the newest version that I have is version 1.6. So if you just upgrade to 1.6, go back into the tests. So we're going to use something called WebSocket.Client. So if you just write a new WebSocket.Client, you should be able to have this one and also this one at your disposal. If you don't see any of these, check that you do have a reference to the API project, and also that the API project does have a package reference to at least one of these. You don't need the WebSocket boilerplate library. I'm going to show you first of all how to do it without it. Then we'll just use this one. This one comes from a NuGet package. I'll open up the NuGet package manager and just search for WebSocket.Client. This one right here is the project that we're actually using. It's just because my project also have a reference to that project. So by default, you already have it installed. And it takes in an argument, which is the URL of the server. And because our startup method by default starts a WebSocket API on port 8181, we're just going to write new URI ws localhost 8181. So here we have a WebSocket client that we can use to send messages to the WebSocket API. So if you give this one a name, WebSocket client, and take the WebSocket client and then start it, and then you can actually start sending messages here. So if you go WebSocket client, send, and then put a string here, hey, it will be able to send it to this address that you have right here. So of course, not only can we send messages to the server, but we can also listen to messages emitted from the server. So we are both listening for whatever the API is sending to us from here while we are sending things to the API. The way it's implemented in the client library is you just write WebSocket client.messages received, and then you subscribe to these messages. So all of these messages for our API will just be the text coming from the API to the client. So let's just start off by logging to the console the message text. So msg.text. So I will just create a very, very quick test here. Var message equals new client wants to echo server DTO, and then just send something like this, and then just put it inside of the send method here, which of course we should transform into text. And serialize the message here. Then we'll just make an artificial delay here, so we can actually see the message coming back from the server when we want to echo the server. So task.delay, I'm gonna put in 5 seconds just to be sure, and then use the wait method here. And before we run this, I'm gonna just add in a string here so you can see very explicitly what is going on, what we got from the server. And now let's just go into the test directory and make a .NET test command here. So the first thing it'll do is it'll start up the API, and then it's gonna go to this test method here, subscribe to the messages coming from the API, and then print this line here with the message text. And this is actually what we're getting back here. This is of course being invoked because we are also sending a message to the server that we want to echo the server. So this is the basics of how a test would look like. We don't have an assertion right here, but we could of course make an assertion based on what we get from the server. Currently, the big problem with this setup is how do we manage time? If this was a synchronous API like HTTP REST, we could just make an await statement and then wait for the result of the HTTP request and then make an assertion. But because we're subscribing to what the server is emitting and we're getting all of the messages up here, but we are sending things to the server down here, doing this becomes kind of weird. So we need a more structured way of working with this. And that's of course what I've already thought about. So when we made the client up here, you might have noticed there was also one called WebSocketTestClient. So this is my implementation of a WebSocket client specifically made for testing. So I'm gonna rewrite this test here using the new WebSocketTestClient that we have here. So by default, it's just gonna assume that you're using port 8181. If you don't, you can just specify the URL yourself. So if you have a different address, you just specify here. Otherwise, it's just gonna assume 8181. And then you just add connect async here. So because this is an async method, we wanna await it, and then we wanna make the method a task which has the async keyword inside of the signature. So now we have the WebSocket client that we need here. We don't actually need to explicitly write subscribe and then do something with the messages. We can't do that if we want to, because I'm just wrapping this on top of the WebSocket client that we used before. So you could use this message received here to subscribe to the messages manually. But it's actually doing that behind the scenes already. So on the WebSocket local variable that we have here, if you use the do and assert method here, so the do and assert method here takes in an action, which is the thing you're doing, and then it takes in an assertion, which is some condition that must be met before we can proceed. So you can do assertions gradually throughout the test method. And the reasoning behind this is that event-driven systems, they rely on previous actions having been taken before they can do newer things. So you don't just test one event in a test, you test a sequence of events and test that the outcome of those events are what you expect them to be. The way you make an action is you just make something that extends the base DTO, because inside of our WebSocket API, all of the transfer objects must extend the base DTO. So if I say new client wants to echo server DTO and put in a message like, hey, I can add in a second argument here. And the second argument is whatever condition that must be met. And it's looking at all of the things we're getting back from the server. And then it's just waiting to see, are those conditions being fulfilled? So if we say received messages and then make a lambda expression here, we need to return some statement about the received messages. You can also call this from server or whatever. And then you say from server. So in human terms, what I expect here to happen is that the server will send an event back to the client now. And that has a specific event type, and that event type is server wants to echo client or server echoes client. Count and then make a lambda expression here. Say that the DTO event type should be equals to the name of server echoes client, and there should be one of these, and then you return this here. So let's just await this one here, because this is an asynchronous method, and then just write .NET test again. And we still have one test that has passed. And just to see that this actually does what we expect it to be, I'm gonna now assert that we're gonna get 2 of these events where the server echoes the client. I know that this doesn't happen, so if I assert that, we should now have a test that fails. And we correctly have a test that fails here. Notice that both arguments here, they are actually optional. That means if you don't have a condition that must be met before proceeding, then you can just leave this one blank. So remove the second argument here, and this is also fine. Now it just won't wait for an assertion to be true. And the reason why it's so important that it waits is because if we have multiple things we want to do inside of this test, let's say that we have await, ws do and assert new client wants to sign in. So first there's a sign in, and then maybe the second one is that we have a client wants to enter a room. So we could have this as the first event, and then this is the second event, and maybe the broadcast is the third event. And each one of these will be executed sequentially. So we only proceed to enter the room once the assertions from this one have all been met. So we're actually going to build this test now that does the sign in and enter room and broadcast. And we're actually going to do this with 2 clients, because not only can you make one WebSocket client, you can have 2 clients in the same test that still interact with each other because they connect to the same API. So if you have one here called WS2 equals await new WebSocketTestClient connect async, these are of course different clients communicating with the same server. So let's duplicate this one here. So we have 2 clients that log in. Username, this is Bob, and username Alice. So good old Bob and Alice. They also they both want to enter room number 1. I should make sure to call this one WS2 because this client is not the same as this client. Duplicate this one here. Enter room number 1 for WebSocket Client 2, and then make the broadcast down here. Client wants to broadcast to room, DTO, still needs a room ID, and then a message. Hey Alice, and then hey Bob, this is WebSocket Client 2. So let's build all of the assertions now. Now we have all of the actions. We're just going to figure out now how are we going to do all of the gradual waiting and assertion processes. So for our code base, we actually don't have any events coming back from these 2 here. So if we go into the production code that actually makes this event here, we can see we don't actually have a counter event. The easiest way to test it is if there is a counter event. So I'll just make a class here. Public class server welcomes user extends base DTO. You don't actually have to put anything inside of this. Like you could make a message if that's what you want to do. But I'll just send this back to the WebSocket client. JSON serialize new server welcomes user. So we're going to assert that we get one of these events here. Go back to the tests. Say that the result should have a count of 1 where the DTO event type equals name of server welcomes user equals 1. And I think we have 1 too many brackets here. And we essentially have the same thing for this client here. And because they subscribe to each of their own events from the server, this is not supposed to be 2. This is actually 1 because it's still only one of these events for this particular WebSocket client. And we're going to make another assertion down here to say that when the client enters the room, there's going to be 1 event of server adds client to room. And the same is the case for this client down here. And now we get to the broadcasting section. Server broadcast message with username. And because when you broadcast a message, you get your own message back. You get one of these events. And then down here for Alice, it's actually 2 because first Alice gets the broadcast from Bob, and then she gets her own broadcast when she says, hey Bob. So now we have a sequence of events emitted by 2 different clients, and we are asserting that the things go in the order that they're supposed to. You could also make assertions about other things than just the event type, but right now I just want to test the correctness of the events being produced. So run it again. And we have a passing test. And just to be 100% sure that this is not some flaky test, if we assert that there should be 3 messages being broadcasted to Alice, we should get a failing test now. And it is correctly failing. And we go back to testing the outcome that we know succeeds here. And of course, if you have tests, you should probably consider automating your tests. So I will make a really quick workflow. Just make a directory here called GitHub. I'm going to use Github Actions. So that's why we have to call it GitHub. And we have to call this directory workflows. Any YAML file that you put in here, the GitHub Actions workflow runner is going to recognize as being a GitHub Actions workflow file. So I want to just call it test. So there's going to be one job inside of this workflow file, and that is just going to be to execute the tests. So I'm going to just call this tests. And now I'm going to say, where should this be running on? And it's just going to be running on Ubuntu 22.04. And there's a sequence of steps. So by using the uses here, we can access pre-existing actions. So there is a pre-existing action called checkout. And the checkout here gives us the possibility of accessing our source code in the repository. This is a very common way of starting out the pipeline, is by being able to access the source code. So we're going to write actions at checkout, and we're going to use version 4. It's the newest major release. And the second one is setting up.NET, so you can actually use the SDK, and you can actually run the program inside of the pipeline. So still start out with actions, and now setup.NET. And this one is also version 4 as the newest one. So by not making an additional dash here, this here pertains to the above step. So we're going to write with, and now we're going to say version.NET version, and we're just going to say 8. So you could also add in a minor and a patch. So we're going to say .NET version 8, minor version 0, and then just the highest patch. So this is a wildcard way of assigning the patch. And now by making a step where you just write run, we're just going to use the default shell that exists on this system. So that means on Ubuntu, there is a default shell which is bash. So we're making a bash command here. cd stands for change directory. So it will just go into whatever directory from the root directory out here. And we want to go into the test directory. So you write cd tests, and then double ampersand like this means when this here on the left hand side is done, do the thing on the right hand side, and that is just .NET test. So now that we have a perfectly valid job, we have to figure out what is the trigger for the job. And we want to trigger this when we make a commit, so we can just write on push. And I'm also going to add workflow dispatch as a trigger. This just gives us a button trigger, so it's nothing fancy really. And let's just commit this to Git. And of course, I forgot to mention, but you should add a gitignore file in here, or a gitignore file in the root directory. It's really up to you where you want to have it. And then also assign bin and object folders in here. And we can see that there is one test passing, and that works out fine because we only have one test.